Hi everyone, welcome to the next lecture in our bit manipulation series. In the previous lecture, we have discussed some basics of bit manipulations. We have discussed some bitwise operators. We have discussed bitwise AND, bitwise OR, XOR, left shift, right shift, okay, NOT. So in this lecture, we'll solve some basic problems using those operators. Okay, so let's take our first example. Let's say we have decimal number 5. Okay, and in binary I can write it like this 0 1 0 1. Okay, for now I am taking only 4 bits. Okay, you can extend it to 8 bits, 16 bits, whatever you want. Till now I am taking it for 4 bits. Okay, for simplicity. Now the problem is I need to check whether my ith bit is set or not. Okay, so let's say I'm starting it from first bit. This is my first bit. Okay, this is my second bit, this is my third bit, and this is my fourth bit, like this. Okay, now my problem says that I want to find whether my ith bit is set or not. Okay, so what does set means? Set means whether my bit is 1 or not. Okay, whether my bit is 1 or not. So let's say I want to find whether my third bit is set or not, means 1 or not. Okay, if it is 1, then do something. Okay, print or whatever. If it is 0, if it is not 1, then do something. Okay, let's say I want to print set and not set. Okay, if it is 1, print set. If it is not 1, print not set. Okay, I want to print this. So how I can approach this problem? We have studied few operators, right? We have studied bitwise OR, bitwise AND, okay, left shift, right shift, okay, not, XOR, right? We have studied these operators in the previous class. Bitwise operator. Okay, now what my idea is, I will try to use them one by one. Okay, I will try to use them to solve my problem. So I will start with bitwise OR. Okay, how I can solve my problem using bitwise OR operator. So my digit was 5, right? And it was 0 1 0 1 in binary. Okay, and I want to find whether my second digit, okay, whether my second digit is set or not, whether my second digit is set or not. Okay, now in bit manipulation I need to perform operation. Okay, I want to perform operation so that only this bit, only this bit I want to find. Okay, only this bit I want to find whether it is 0 or 1. Now remaining bit I don't care. Okay, for this bit and for this bit I don't care. So what operation I want to perform? Okay, I want to perform some operation so that I can find whether my this bit is set or not. Okay, so let's start with bitwise OR. Okay, if I take bitwise OR, this is a symbol, right? Now what if I take, okay, let's say if I take 0 0 0 0 to bitwise OR, what will happen? It will result in 0 1 0 1. Okay, so it will result in same as my problem. So it doesn't affect, right? It doesn't affect my answer. Now what if I take it all once? Okay, what if I take it all once? What if I take it all once? What will happen? See, bitwise or of 1 with anything will be 1 only. So all will result in 1. Okay, so I need to think something else. Okay, so using zeros and using all ones will not work, right? So I need to do something else, right? I need to do something else. By the way, this process, see, this process we call it as mask. Okay, I want to create a mask, and by using bitwise operators and creating mask, I want to find my answer of problem. Okay, so if I take 0 0 0 0 as mask, I'll not get answer. If I take 1 1 1 1 as mask, I'll not get answer. But why I'm taking all zeros and all ones when I want to find only this, when I want to find the value of only this bit, correct? So we'll think of something else. So I need to take care of this bit only. Okay, so from now I'll create a mask which will handle this bit, especially. Okay, So what if I take something like 0 1 0 0 as mask? What if I take it as mask? So if I take 0 1 0 0 0 1 0 0 as mask, what will happen? So it will be 0. Okay, let's write this first. It will be 0, it will be 1. Now I have taken 1 here as mask in mask. Okay, I have taken 1 here. So if I do bitwise OR with 1, it will result in 1 only. It will result in 1 only. Okay, so if every time it will result in 1 only, then there is no benefit of taking it as 1. Okay, so I cannot take 1 with bitwise OR. Okay, because it will always result in 1. It will always result in 1. So I need to do something else. Okay, so this also cannot be our mask, right? Now by seeing these masks, we can say that if I'm taking 1 with bitwise OR, it is always resulting in 1. Okay, so we cannot get answer. We cannot find whether my bit is set or not. If I'm taking 0, if I'm taking 0 with bitwise OR, it is always resulting me the same. Okay, so if it is giving me the same, then what's the benefit of taking the mask, right? Now let's try using some other operators. Okay, let's try taking AND operator. So if I take AND operator, this is my 5. I will write it 0 1 0 1. Okay, I want to find whether this bit is set or not, and I want to create a mask. Okay, I want to create a mask with bitwise AND such that I can get whether it is set or not. Here also I will try to create a mask. So if I take 0 0 0 0 as a mask, okay, what will happen? If I take 0 0 0 0 and do a bitwise AND, what will happen? Everything will result in 0. Okay, so if I am taking all zeros as mask, what will happen? The end will be all zeros. Okay, now if I take all ones, if I take all ones, if I take all ones, what will happen? It will result in 1. This will be 0. This will be 1. This will be 0. Okay, so again it is same as my problem. Okay, it is same as my problem. So still this all ones cannot be our mask. Okay, this cannot be our mask. Now let's take some combination of zeros and ones. Okay, so I want to check this bit. I want to check this bit whether it is 0 or 1. So what I can do, I can take, let's say, 0 1 double 0 combination. Okay, and then I will try 1 0 double 1 combination. Okay, these two combinations I will try. So let's try with 0 1 double 0 0 1 double 0 combination. Okay, so if I take 1 and 0, it will be 0, it will be 0, it will be 1, and it will be 0. Okay, so this is giving me 1 at this position. Okay, at this position it is giving me 1. Now what if this bit is 0? What if this bit is 0? If this bit is 0, it will give me 0 here. So I hope this can be used as a mask. Okay, let's take some more example. Let's say if I take 7. Okay, 7 will be 0 triple 1, and I want to find whether third bit is 1 or not. Okay, so what I can do, this is my first bit, this is second bit, this is third bit, this is fourth bit. Okay, so I will take 1 here and all zeros. Okay, now if I do bitwise AND, it will be 0 0 1 0. Okay, so if it is non-zero, if it is non-zero, see this, the value of it will be 1 2 4 4, right? So it is non-zero. If it is non-zero, if it is non-zero, can we say that the bit is set? Now if it is 0, let's say 7 in 7 only. Okay, I want to find whether fourth bit is set or not. So let's take 7. 7 will be this. Okay, and I want to find whether this bit is set or not. So I will take a mask. I will take a mask, put this as 1 and rest as 0. Okay, and I will find, so this will be 0, this will be 0, this will be 0, this will be 0. Okay, so it is 0, it is 0. So can we say that if it is 0, that means the bit is not set. The bit is not set. Okay. So till now what we have done, I am taking a mask. Okay. If I am taking a mask, okay, and taking one at the ith bit, one at the ith bit, and remaining 0, remaining zeros. Okay. That we will see how we can create this mask and perform a bitwise AND with it. If it is 0, if it is 0, that means the bit is not set. If it is non-zero, if it is non-zero, then that means the bit is set. Okay, so let's take 2 3 examples. Let's say in 9, I am taking 9, so it will be 1001. Okay, I want to find third bit, so it will be, my mask will be 0100. Okay, and if I do bitwise AND, it will be 0000. Okay, and it will result in 0. So 0 means not set. Okay, and if I want to find first bit, so this will be, my mask will be this one, right? And if I do bitwise AND, it will be 1000. So it is non-zero. It is non-zero. That means bit is set. Okay, if I want to find whether fourth bit is set or not, so if I take 1001, okay, it will be 1. I'm taking this as 1 and rest as 0. Okay, do bitwise AND, it will be 1000. Okay, it is nothing but 1 2 4 8. 8 is not 0. Okay, so I can say that it is set. That means this bit, my fourth bit, is set. Okay, so I can create a mask. I can create a mask. Okay, I can create a mask in which I will take 1 at ith bit and remaining will be 0. How I can take that? So we have studied about left shift and right shift, right? We have studied about left shift and right shift. So if I take one, if I take one, okay, and I want to put one at ith place, at ith bit, and rest should be 0. Rest should be 0. So how I can do that? How I can do that? By using left shift or right shift operator. So if I'm taking one, if I'm taking one, okay, let's say in 5 only. In 5 only, I want to find, let's say, third bit. Third bit. So my mask will be nothing but 100. Okay, I will take this as mask. This should be 1 and rest should be 0. Okay, so this will be my mask. How I can create that? So in this, my eye is third, right? And I want to find third bit. So my mask is 0100. Okay, now if I take 1 and if I do left shift by 2 times, what it will be? It will be 100, right? And before it will be 0 only. So I can say that if I take 1 and do a left shift by I minus 1 times, I minus 1 times, I can create my mask. Okay, so my mask will be 1 left shift I minus 1 times. Okay, so to check whether my bit is set or not, so I can create a mask by taking 1 and left shift it by I minus 1 times. Okay, and perform bitwise AND with my number. Okay, so it will result me, if it is 0, that means bit is not set. If it is non-zero, that means the bit is set. Okay, I hope you understood it. Take 2 3 examples, you will get it. Okay, now let's move forward to next problem.